Hello students, welcome to the second day of this bridge course. I am your personal math mentor Venkat Santosh from Chaitanya. Right, so yesterday we were discussing about rational numbers, real numbers and irrational numbers also. At the end we were giving imaginary numbers and complex system, how it was invented, why we required and what are the real applications and all these things. Today we are going to talk about the surds that yesterday we were discussing about the irrational numbers. Some of them are surds there. Okay, na? So I am going to give the definition for that one first. That is definition of surds. So if I am going to take any number A is there, which is right. So A is any number here, that is rational number. And if I am going to write A power 1 by n, or you can write nth root of A, that is called a surd. And you can give the order for this surd, that is nth order surd over here. And there are some examples here. We can see root 2, root 3, root 5, root 6, and also you can take cube root of 2. All these you can see this order here of surds is 2. And you can see here up to cube root of 6, order is 3. And here all these order is 4. And this one fifth order. All these are surds and they are irrational numbers. For example, if I am taking square root of 4, this is not a surd because square root of 4 we know that it is equals to 2. Not only that, if I am taking cube root of, let's say 64. Now we know this value here, this is going to be equals to 4 because 4 can be multiplied 3 times. That 3 is going to get cancelled, which is going to give us 4 over there. So cube root of 64 is also not surd because that should be an irrational number. Cube root of 64 is giving us 4, that is why it is not irrational number. Now let's go to the next. In the definition we have some remarks. One is that nth order surd nth root of A is also called as simple surd, and it consists only one term. If I am going to take two terms like this, let's say root 2 plus root 3 is there. This is not a simple surd. We are going to learn about this again later. And then if I am going to take one surd, there is a possibility of two orders at a time. For example, you take fourth root of 4 also can be written as square root of 2 also. Square root of 2 if I am taking, as you can see, it is going to have second order. Square root of 2 if I am taking, that order is 2 we are going to denote, right? And then we have classification of surds, and first one is that quadratic surd. You can see that here root 2, root 3, root 5, root 6, all these means here 2 power or square 2th root of 2, or you can see here 2th root of 3, and square root of 5, square root of 6, all these are quadratic surds. Then cubic surds, obviously, if you are taking cube root of 4 if I am writing, that is a surd here whose order is 3. If order is 3, then that is called as cubic surd. And then biquadratic, same way we are taking the order as 4, that is giving us biquadratic surd. We have some examples have shown already, and then we are going to take classification of surds. In that again we have fourth classification, that is mixed surds. If you are going to take some rational number adding to a surd like this 3 minus root 2, and you are going to multiply a rational number here, that is root 3 into 5, that is also called mixed surds. You are just multiplying or adding and subtracting, and you are just giving algebraic operations for all these surds, including rational numbers. All these are called mixed surds. Okay, na? And then we are having compound surd also, that you are going to involve more than two surds. You can see here a root 3, a root 2, and a root 5 plus root 7 is there multiplied by a rational number. If you are going to have more than two surds, that is called as compound surd, right? So that is how we are going to classify these surds, and let us find what are the mixed surds out of these four surds. Now you can see cube root of surd, you can write it as here 2 power 4 here, and cube root of 4 is there. So you cannot write this one as mixed surd, you cannot take 2 outside there. But what about this one over here? This one you can write directly 2 power 4 whole power 1 by 4 is there. These two are getting cancelled. You are going to write it as 2. This is not surd at all. So it's not mixed surd also. Now 4th root of 8 is there. This one also we cannot write as this mixed surd by multiplying any number or taking any number from the surd outside. So that is not a mixed surd. What about the last one? You can see a rational number is there. A surd is there multiplied by them. If I am going to take, that is going to be what? Mixed surd. Okay, na? So that is how we are going to take mixed surds out of these 4. And we are going to write the simplest form of the surd here. 4th root of 112 is there. I am going to write the factors of 112 there. 112 factors you can write it as 4 into, first if I am going to multiply 2 here, 2 into, you can write there 56. And 56 also can be written as 7 into 7 times 8. 8 into 2 is giving us 16. 4th root of 16 times 7 I am writing. 16 also again can be written as 2 power 4 into 7 whole power 1 by 4 is there. Now you can separate them. So you can write 2 power 4 whole power 1 by 4 into 7, which is giving us, 7 power 1 by 4, which is giving us 2 times 7 power 1 by 4. Or you can write in surd form, that is 4th root of 7. So which is giving us mixed surd, and that is a simplest form, right? And then we are going to compare two surds. Let's say I have 2 power 1 by 3 is there and 3 power 1 by 2 is there. We don't know the exact value of this. We can get approximate values. There are some methods there, but we are not using them to get the approximate values. But we are going to still compare these two surds over here by taking, what is the LCM of 2 comma 3, that it is going to be 6 there, right? So 6 I am going to take power of 6, 2 power 1 by 3 whole power 6 I am taking, and 3 power 1 by 2 whole power 6 I am taking here. 2 power, you are going to get 6 by 3, you know that number is 2 here already, 2 square, and this is going to be 3 cube. Now 2 square if I am taking, that it is going to be 4, and 3 cube is going to give us 9. Then you can see that 9 is obviously greater than 4 there. So what is the number which is going to be greater? 3 power 1 by 2. Now I am going to give a question how you are going to compare this. Okay, na? So I am giving 2 power 1 by 2, 3 power 1 by 3. Please compare and give me the answer which is going to be greater in these two here. I am waiting for the answer. You should all give that 3 power. Sorry, 3 cube is 27. Still it is going to be big over here. Right. 3 power 1 by 3 is big. Very good. No, Samir. It is actually 3 power 1 by 3. Bhargavi, you did correct. That you are taking power 6 on both for both the numbers. So 3 power 1 by 3 whole power 6 here, which is going to give us 2 power 3 here and 3 power 2. 2 power 3, 8 and 9 here. So we know that 9 is greater than 8. So the number which we have taken power 6 over here, 3 power 1 by 3 is going to be bigger than 2 power 1 by 2. So the concept of rationalization, by using that also I am going to compare other two surds there. Okay, now I am going to show you that also. Then we have square root of a surd. This is very important. A lot of JEE questions are going to be use this concept square root of surd here. Okay, now I am going to give a simplest form here. We know already yesterday I have given that identity of a plus b whole square. What is that? A plus b whole square can be taken as a square plus b square plus 2ab. Okay, now what if I am going to write this one over here, root x plus root y whole square, which can be written as x plus y plus 2 into root x into root y. Correct? Now what if I am writing this square on the right side, which is going to give us root x plus root y is equals to square root of x plus y plus 2 into root x into root y. So we need to find we need to find the values x and y whose sum is going to give us over here, and product over here root x root y. Total you are going to get root x plus root y whole square. The square root is going to get cancelled. Let me give an example on that. You can find simply like 4 plus, if I am taking 2 root 3 is there. So I just need two numbers whose multiplication is root 3 here, because 2 already fixed over here, 2 already fixed over here, right? And sum of the squares is going to be giving us 4. So you think of that numbers. Okay, you can see that square root of, I can write 4 as 3 plus 1 plus 2 into root 3 into 1. Why don't I write 3 as root 3 square there? So you are going to get square root of root 3 whole square plus 1 plus 2 into root 3 into 1. Isn't it the form of a square plus b square plus 2ab, or x plus y plus 2 into root over x into root over y? The same thing is here. So you can take in the place of a, we are having root 3, and in the place of b, we are having 1. Now you can write a plus b whole square form, right? So that is equals to square root of 3 plus 1 whole square. Square root and square is getting cancelled. We have left with root 3 plus 1. This is a simple example. In the further slides, we are going to learn more of this, and we are going to use and we are going to solve brilliant questions. Okay, now you can see root over 8 plus 2 root 15. I am going to give this one. You have to solve this one, right? So I am taking here root over 8 plus 2 into root 15 can be taken as root 3 into root 5. I am just writing the factors. I am just checking whether we are going to get the squares, sum of the squares is going to be 8 or not, right? So I am taking root 3 and root 5 here. Square root of this can be written as root 3 square, which is 3, and root 5 square, which is 5. So 3 plus 5, you can see that is 8. So 8 plus 2 root, that this is a square plus b square plus 2 into a into b, which can be directly taken as root 3 plus root 5 whole square, which is equals to root 5 plus root 3. I think everybody understood that. Now please solve this question. I am going to see that chart box. Very good, Venkat Subbarao, you have got the correct answer. What about the second one? Second one is x is equals to 2 and y is equals to 3. Are you sure? Are you sure about that? Root 3 minus root 2 is correct. Bhargav Sai, very nice. So you are going to take here square root of, this can be written as root 3 whole square plus root 2 whole square minus 2 into root 3 times root 2, which is going to give us root 3 minus root 2 whole square. Okay, so square root is getting cancelled. You can write square root of 3 minus square root of 2. But why it is not square root of 2 minus square root of 3? Why we are not going to get that? Sir, ఒకసారి sound check చేసుకోండి. Yes. Right. So sum of these two numbers, you can see that 2 plus 2 is giving us 4. You can see that. And if I am going to multiply, what is going to be that? So yesterday I have given the identity that a plus b into a minus b is equals to a square minus b square, which is going to give us 4 minus 3 is equals to 1. So there you can see that we are getting a rational number. On multiplication. On addition, you are getting a rational number. If you are going to get an addition or multiplication, if you are getting a rational number, those are called as conjugate to each other. These rational numbers are conjugate to each other. So, and this a minus b is called rationalizing factor also for a plus root b. And a plus b root b is rationalizing factor to the other number a minus root b. And then let us see some of the examples. Just now I have given 3 plus root 2 and 3 minus root 2 are the conjugates to each other. 5 minus root 3 and 5 plus root 3, you can see that wherever root 3 is there, for that one we are going to take what? Sign change here. Here minus is there, here we need to take plus, so that you are going to get the conjugate. 3 plus root 5 and 3 minus root 5, right? And the sum of the two conjugate rational numbers is going to be what? Rational number. One more example is there by taking these two numbers we are taking. And two binomial surds if you are taking are said to be conjugate surds if their sum and product are rational number. Just now I have told you that their sum and product must be rational number, which is going to give us what? That conjugate surd. And then you can see that, let's say there is a number like this, square root of 8 is cube root of 4 is there. Now what number we should multiply this one over here to find rational number? That I know that this is 2 power 2 here, cube root of, now I just need one more 2 here for the square root here. So you are going to get what? A rational number. That is why I am taking here 2 power 1 by 3. Now you can see 2 power 2 by 3 times 2 power 1 by 3 is equals to 2 power 3 by 3, which is giving us 2 here, right? So we are getting a rational number. That is why 2 power 1 by 3 is our rationalizing factor in this case, right? And the same way you can see that 3 minus 2, cube root of 2 if I am taking, rationalizing factor is cube root of 4. Just now I have explained that. And rationalizing factors said it's not unique, you are going to have more also. For example, this one here 2 power 1 by 3 I am having, I can take, so I have here cube root of 4 is there. For this one I can multiply not only 2 power 1 by 3, but also you can multiply 2 power 4 by 3 also. This one also is going to give, on multiplication of these two numbers you are going to get 4. So that one also you are going to take as rationalizing factor. So that is not unique, right? And rationalizing factor of this one, again root a, root b, there is a compound set. When you are taking root a plus root b, then your rationalizing factor will be root a minus root b, because this product is going to give us in this case as a rational number, right? And what is the rationalizing factor of cube root of 81? 81 you can write here as 3 power 4. Now here we are having whole power, cube root of 81 is nothing but whole power 1 by 3 we are writing, which is giving us 3 power 4 by 3. We just need here 2, so that we are going to get an integer by adding these two here. So which is going to be 4 plus 2 is giving us 6 by 3, which is 2 there. So 9 you are going to get. So 3 power 2 by 3 we need, 3 power 2 whole power 1 by 3 we need, that is this here, right? So 3 power 2 is 9 there, 9 power raising factor to get what? A rational number, right? So now again we are going to find the square root of this. Already we found this, but here plus is there. Previously I was taking minus, so in this case it is going to be what? Plus we are going to take, right? And then we have x is equals to 2 by 3 plus root 7. I am going to take now rationalizing factor for this one to get this entire surd in the numerator, so that I can simplify. So that is exactly what I am taking. X is equals to 2 divided by 3 plus root 7 is there. Our rationalizing factor will be 3 minus root 7. 3 minus root 7 I am multiplying and dividing. What will be the numerator? 2 into 3 minus root 7. So what is the denominator? that 3 into 3, 9, a plus b into a minus b, 9 minus 7 if I am taking 2, 2 is getting cancelled, then x we have left with 3 minus root 7. What will be x minus 3 is equals to then? Yes, minus root 7. Yes, it is correct. My root 7 is correct. So you are going to get x minus 3 whole square is equals to root 7 minus root 7 whole square, which is 7. Our answer is 7 here. Right. I think you are finding somewhat easy these questions. Right. So you are getting the answer. Very good. Now let me give you a somewhat different question here, that x is this. Now we need to find x plus 1 by x. So there are options here 4, 6, 3, 2. Let us check what we are going to get as an option here. X is equals to this. I am taking square root of, first we need to remove the square root. For that one, what we are going to do? Right, we are going to take square root of this number, perfect square we need to make. X is equals to, I can write square root of 7. I am writing as here 7 plus, we need to get 2ab form first. So 2 I am writing into 2 into root 3 I am writing. So 2 square is 4, 4 plus 3 is going to be 7. That is exactly is there here. Square root of, I can write this one over here as 2 square because that is a square, and here it is root 3 square, that is b square, and plus at the end we are having 2ab, that is 2 into root 3, which is equals to square root of 2 plus root 3 whole square. Square root and that is getting cancelled. We have left with 2 plus root 3. Very good. We have got 2 plus root 3 for x there. Now let us substitute in the given expression. X plus 1 by x is equals to, x we have got 2 plus root 3 and plus 1 divided by 2 plus root 3. To add these two numbers, I need to rationalize again. That we are going to multiply as 2 plus 2 minus root 3 divided by 2 minus root 3. That is a rationalizing factor, because if you are multiplying these two, you are going to get what? A rational number. So 2 plus root 3 plus, so 2 minus root 3 in the numerator. This is going to be a square minus b square, that is 4 minus 3, which is giving us 2 plus root 3. This is 1 here, 2 minus root 3. Root 3 is getting cancelled, 2 plus 2. That is simple 4. 4 you are getting as the answer. First option is correct for this question, right? Next, let us see one more question on this. So this is somewhat bigger expression. I am giving you to solve this question. I am waiting for your answer. Please work on that. Work on this question. X is equals to, you have a bigger number here, half times root 3 plus 1 by root 3, and we need to find square root of x square. Somebody is getting 2, somebody is getting, okay, this 4 you have done with that already. Very nice. Very nice. Nice, 1 you are getting. Let us see. Some of you are getting 1. Let us see what we are going to get for this one. X is equals to half into, you are having this, but we need to find x square minus 1 also. For that one, I am going to take x square. X square is equals to 1 by 2 whole square is giving us 1 by 4. And square of this one is giving us root 3 square is 3. 3 plus 1 by 3 plus, now you are going to take here, if I am going to take 2ab, that is giving us what? The 2 here, right? And right? So 2 you are getting. Let us simplify this. What we get here in this x square value you are getting very simply. That is going to be 1 by 4 times of 9 plus 6 is giving us 15 plus 1, 16 divided by 3. 16 divided by 3 is equals to 4 by 3. 4 by 3 you are getting x square value. What will be x square minus 1 value? Which is going to be 4 by 3 minus 1, and that is going to be 1 by 3. right? So 4 by 3 minus 1 is giving us 1 by 3. So substitute 1 by 3 x square minus 1 in the place of this. Then we have square root of 1 by 3 divided by x value we are writing here 1 by 2. And I am taking LCM. LCM if I am going to take, that is going to be 3 plus 1. 3 plus 1 if I am writing, that is going to be 4 by root 3 and minus 1 by root 3 in the place of x square minus 1. I am just substituting 1 by 3. So what do we get here? 1 by 3 is getting cancelled in the numerator and denominator. You can see root 3, same LCM for the denominator, right? So root 3 is getting cancelled. We have left with 1 by 4 by 2 minus 1, which is equals to 1 by 2 minus 1, which is 1. Very good. All of you getting answer. Very nice. Right? Now let us see this one here. You are going to use rationalizing factor as well as and square root of a number also. Right? So x is equals to, I am writing here numerator as, already we have solved this question, that can be written as what? Root 3 plus 2 whole square, and denominator, that square root is getting cancelled. We have solved recently this question, and square root of 7 minus root 3 can be written as 2 minus root 3. Right. So what will be x square of this one here? X square if I am writing, then you are having 7 plus 4 root 3 divided by 7 minus 4 root 3. I am just taking the number what they have given here, squaring on both sides you are getting. So if you are taking square root, you are getting x value. Why we need x here? Because in the expression that we need to find, there is x over here, right? So to find x there, we need to simplify this one here, and you are going to take the square root of the numbers there, right? So these two I am just plugging in the given expression to get that. Okay, so plugging in these two, 7 plus 4 root 3 divided by 7 minus 4 root 3, and then into x minus 14 if I am writing. What will be that? X minus 14 if I am writing, this is x here, that is 2 plus root 3 divided by 2 minus root 3 minus 14. Why don't we rationalize this one here? I am going to rationalize this. What do we get? You check here. That is going to be, denominator is going to be 1 only, and the numerator is going to be 2 plus root 3 whole square. And you can substitute in this. So this value I am simplifying. So and again rationalizing this one here, 7 plus 4 root 3 whole square divided by 49. And what is 4 root 3 whole square, right? 48 there, into, and here the same way 2 plus root 3 whole square here having minus 14. And you can simplify further. This value is 1 there, this is 1 there. And what about this? 7 plus root 3 whole square you are writing. Right. So what will be this value here? 7 plus 4 root 3 whole square. And here you can write here 2 square is 4, 7 minus, that is giving us minus 7. And 7 minus if I am writing, that is going to be 4 root 3, right? So you just multiply with this one here, you would get, and x square you are writing there, and square is also there for this expression, second expression, square I forgot, sorry for that, and square, both squares are there, you can multiply these two, which is again giving us 48 minus 49, because this is a square, this is b square, a square minus b square whole square, which is minus 1 whole square. So the answer is 1. Okay, na? So that's simple if you know already the rationalizing factors as well as square root of a third over there, right? Right. So let's see one more. Now there are different expressions here, same expression here, same expression here, but there is a symbol difference here. In the numerator plus is there, in the denominator we are having minus. So let us simplify this one also, right? Directly now you got to know how to write this perfect square there. So I am directly writing, okay na? So anybody guess what is a perfect square for this one? Instantly how do you write that? You can see that root 28 is there, root 28 also can be taken as. Right. Yes, good. That if I am writing this one here root 7 plus 1 whole square, because I can see that this one can be written as 2 into root 7 into 1. So root 7 is there, plus 1 is there, root 7 square is 7, plus 1 if I am taking, that we are getting as 8 there. So you are writing this one as root 7 plus 1 whole square. So I am just cancelling that square root and square here. Then we have left with just root 7 plus 1. This one here is going to be root 7 minus 1. Denominator also root 7 plus 1 minus root 7 minus 1. What do we get in the numerator? That is 2 root 7, sum of these two. And what we are going to get the denominator? That it is going to be 2. 2 is getting cancelled. We have left with root 7. Root 7 is our answer. It's as simple as possible. You can see directly you are writing this one because you have done practice on that. Okay, no? So if you are doing practice in this way, you can get to know what directly the square root of a number, right? And this one, I am going to challenge you to solve these problems. If you are finding it good, you can in the chart box you can write down. There is a sequence of numbers. Let me know that you can see the question or not. We need to find the values of A, B, C to get the value A plus B plus C. Right, very nice. And some of you are trying. Right, let us see that. Now you can see that there is a series with numbers here 3, 5, 5, 7, 7, 9, all these are odd numbers there. So to add these numbers, I need to be them in the numerator. For that one, I am going to rationalize. So 2 divided by, so what is the rationalizing factor for this one? We know that it is root 5 minus root 3. So I am just taking bigger number first here so that I am going to get positive number for this in the numerator. And in the denominator you can see that is 5 minus 3. The same way second term also you can write here 2 into root 7 minus root 5 is our rationalizing factor, right? So in the denominator also you are going to get 7 minus 5, which is going to be 2. Now the same way you can write all these numbers to the end, that is going to be 2 into rationalizing factor root 13 minus root 11 whole divided by 13 minus 11. And the last one I am going to write here, so which is going to give a pattern. Let us see we are going to get a pattern or not, right? So 2 times root 15 minus root 13 divided by 15 minus 11, right? So let us simplify further that 2 is getting cancelled with the denominator because 5 minus 3 is 2 there, and same way here 7 minus 5 if I am taking, that is also getting cancelled. All these numbers are getting cancelled there. So you can see that in the numerator we have left with root 5 minus root 3, and here we have left with root 7 minus root 5, and next one obviously is going to be root 9 minus root 7, and then root 11 minus root 9, and here you can see that root 13 minus root 11 and plus root 15. Last one is root 15 minus root 13. Now you can see some of these terms are getting cancelled. Let us see what are those. And 5 root 5 and root 7 are getting cancelled. Root 9 here is getting cancelled. Root 11 is also getting cancelled. Root 13 is also getting cancelled. Here plus is there, there minus is there. So all these are getting cancelled. We have left with root 15 minus root 3. So root 15 minus root 3 again, but on the right side we have A here, B and C. but in the denominator you can see square root of b plus is there. Now I am trying to, but this is only numerator, there is nothing in the denominator. That is why I am trying to convert this one and bring it to the denominator by using rationalizing factor. So what is the rationalizing factor? This one, for this one, we are going to take the rationalizing factor, that is root 15 plus root 3 whole divided by root 15 plus root 3. Okay, na? So which is going to be equals to, what is this multiplication here? A minus b into a plus b is there. So what will be the multiplication of this? 15 minus 3 divided by, now here only one term is having square root, one is not having. That is why I am going to take one of them is 1 over there. To get 1 there, I am going to take common one of these factors here. Root 15 can be written as root 3 times of root 5 plus root 3, which is equals to 15 minus 3 we know, that is 12 there. So what, something is common in the numerator, that is root 3 into root 5 plus 1, which is equals to, again this root 3 is extra is there, but in the denominator it is not there. That is why I write in the numerator 4 into 3 into root 3 into root 3. We know that root 3 into root 3 is going to be 3. 3 into 4 is 12. So 12 I am writing like this. Why I am writing? Because in the denominator we have root 3 to cancel out. Right. So root 3 is getting cancelled now. So 4 root 3 can be written as again square root of 48, because 4 can be written as square root of 16. Divided by, we have left with root 15 plus 1. What is root 48? Here root 48 is there. Now you can compare this entire number with this one here. Tell me what are the values of A. A is going to be obviously 48 and B is going to be, we are having 15 there, and C is equals to 1. Sum of all these numbers we need. So that is going to be 48, 15, C if I am taking 1 there. Then we take, sorry, one small mistake here. That is here, this is not root 15, this is only 5. Okay, na? Because we have taken root 15, if I am writing root 3 into root 5, root 3 we have taken common. So that is going to be root 5 here. Root 5 we have left with, and this one here, this is 5 here, because B is equals to 5. Now you can see 5 and 48 are co-prime here, because its highest common factor is 1 only. So that is why they are co-prime now. Now you can add all these numbers. What we are going to get? 48 plus 49 plus 5 here, we are getting as 54. 54 is our answer. 54 is the sum of the numbers. So in that way, if there is any sequence like this, you just need to remember that how to take what? Rationalizing, so that all the terms are going to be in the numerator, and then you can add them, and some of the terms are going to get cancelled. Definitely there will be a pattern in any of these questions. If you like this question, please show thumbs up in the chat box. Very good, Arish. You have got 54. Very nice. Purnima, nice, nice, very good. Lakshmi Kalyani, please check the answer. I think it is 45, it's not 54. If you are feeling that you are learning some new things over here, write down wonderful in the comments. Right? So this is how you are taking. I am telling you once again, if there is a question like this, there is a possibility that now we are going to learn AP, GP and all the sequence and series. In that there is a possibility you are going to get up to n terms there. So it doesn't matter what are the number of terms there. There is a concept of calculus in that you are going to have limits, differentiation, integration. In all these kind of series are going to be appearing, and in that you need to check the pattern where how you are going to get. To get the pattern, we need to simplify like this by taking rationalization and all these things, right? So that is why we are learning now, so that there we are going to easily solve the problems, right? Next, so this one here, bigger one is there. There are number of roots here. You can see that. Yes. Thank you, Sahil. Thank you, Rani. Nice. Right. So here you can see that 17 and 4 root 15 is there. Now if I am not going to take square root of, then you cannot take it outside. That is why I am going to write this one over here as 2 into, and 2 I am going to take here 2 and root 15 is there. But 17 is not giving that. That is why I am going to multiply this one as 2 into root 3. 2 I am writing as root inside the root, so that I can conclude what are the factors which are going to be giving us 17 as sum of the squares. Okay, no? So 2 I am writing as square root of 4 and square root of 5. Now you can see 3 into 4, that is 12, and 5 is there. 12 plus 5 is giving us, yes, 17 we are getting, right? That is why I am going to take these are the factors here. So the factors that we have got are that 2 and root 12 and root 5. And this can be written as again a root 12 whole square plus a root 5 whole square. Minus is there. So you can write this entire expression as a root 12 plus root 12 minus root 5 whole square. Now you just have to substitute in this. Square root and square are getting cancelled. What we have left with, I am going to write the entire expression over here. So square root of 3 minus square root of 4 plus root 5, and this part here we have got it as root 12 minus root 5. Root 5 is getting cancelled here. We have left with square root of 3 minus square root of and then we have left with 4 plus root 12. Again I am trying to get this perfect square, so that it is going to be simplified further. Square root of 3, this can be written as again root 12 can be written as 2 into root 3. So which is giving us, here minus is there. Right. Tell me what we are going to get here. That yes. So this is going to be root 3 plus 1 whole square. Square root is getting cancelled with the square there, and root 3 is getting cancelled. Minus of plus 1 here we are getting as square root of minus 1. Yesterday we were learning about imaginary numbers, that is going to be equals to iota, right? So square root of minus 1 is always iota. So we are getting this here, and you can see that option 3 is correct for this question here, right? So there are number of roots. Still we have simplified if you get to know how to solve square root of a surd, right? Then the last one we are taking here, 4th root of 97 plus 56 root 3 is there. How you are going to simplify? All of you work on this. This is the last question. Yes. Okay, so there are, yes, one was correct. I we were getting, very nice. Right, so here is the last question we are going to solve. You can see that 4th root of 97 plus 56 root 3 is there. So I am trying to write again the same way that we have taken square root. We have 4th root of 97 plus 56 root 3 is there. So that I am writing here as 56 I am going to take 2 times of, 56 can be taken as 2 times of 28 if I am writing square root of 3. 28 again can be taken as 7 times 4 there, square root of 3, and this I am writing as 2 into this one over here, 7 into square root of 48 I can take. Now 7 square is 49 and root 48 square is going to be 48. Sum is giving us, these two sum is giving us 97. That is how we are simplifying here. You can see that 97 we are writing sum of the two numbers, that is 7 and square root of 48, which can be simplified further. As you can see, this is a square, that is root 7 square, and this one here root 48 whole square, and plus we are having 2 into 7 into root 48. Total. So this entire expression can be taken as fourth root of this one perfect square we were getting, that is going to be 7 plus root 48 whole square. Okay, na? So again here we have power 4, power 1 by 4, nothing but 7 plus 2 into square root of, this can be written as 16 if 4 if I am going to take here, that is going to be 12 there, whole power 2 whole power 1 by 4. So 2 times it is cancelled, then we have left with only 2. Then 7 plus 2 root 12 can be taken again as that. So 7 plus 2 into, then we are having here 2 into, or 4 if I am writing, 4 into 3 you can write. And 1, 2 is getting cancelled, we have left with only 1 by 2. Now this can be taken again perfect square, that is going to be, you can see that root 3 plus 2 whole square, again square root is getting cancelled with 2 there, we have left with root 3 plus 2. That is how you are going to solve if there are square root 2 times also, right? Right, so that's it about surds. See, all these concepts that we have discussed definitely will be helpful in your JEE coaching. Okay, now somewhere you are going to get, like as I told you, sequence and series, integration, differentiation, and some of the concepts of limits and all these things, right? So you need to learn this, you need to work on this, you try to solve some more questions and practice on that. So thank you very much for joining the session, right? It's your personal math mentor Venkat Santosh. Thank you.